Hello, folks. Hope you are all doing great today and excited for this webinar. And yeah, happy Tuesday, I guess. Hopefully you can hear me.
Yes, we can.
Amazing. And that is Ben, who is today's webinar host as well. So let me stop sharing my screen quickly and hand over to Ben to be the host. Once I figure out the Zoom controls, you thought I would be a pro at this by now, right? There we go. Make host.
I don't think Zoom controls are the thing to be pro in life. There are so many cool other things, AWS, GCP.
Exactly. So you are now the host, sir, and feel free to share your screen. I will just turn off my video so you have the video as well. I just want to say, folks, welcome to the webinar, Continuous Integration, Continuous Deception, Trying Our Luck as Malicious Maintainers. So today we are extremely fortunate to have Ben Haußner with us to present this webinar today. So Ben is a red team operator and also Pwned Labs contributor. And I will leave Ben to introduce himself properly in a minute also and what this session will cover in more detail. Just to give a bit of an overview that this session today will demonstrate how an adversary with maintainer level access to a repository can stealthily tamper with releases built by GitHub Actions to potentially poison entire supply chains, as we saw in the recent NPM attacks also. So yeah, I will hand over to Ben today. Ben, thank you so much for being here and sharing your knowledge with the community today.
Thank you so much for the introduction, Ian. Good evening, everybody, or good morning, wherever in the world you are. It is a big honor and pleasure to be here tonight. I have been an avid Pwned Labs student and now contributor, and that is really cool to be able to give something back. I'm super happy that so many of you are interested in CI/CD security. This is an absolute pet peeve topic of mine, and that's one of the reasons why I spoke at this year's Forward CloudSec Europe like a month ago. And I had 20 minutes to go through this, and it's quite a bit. So I reached out to Ian and was like, hey, can we maybe do this, but also with live demos and get more into the details? And luckily he said yes, so that's really cool. I'm guessing he will be monitoring the chat. If you guys have any questions, let us know, and I'm happy to answer them. Wonderful. I'll jump right in. What we're going to do, or how we're going to do this, I will basically stick more or less to the presentation I gave at Forward CloudSec. But since we now have 3 times the time, I will branch out left and right, and we will go through the stuff live. So, continuous integration, continuous deception, trying our luck as malicious maintainers. Supply chain attacks are a problem. I think when you're here, you know about this. There were, as Ian just said, many breaches in NPM lately. TJ Actions changed files. Amazon Q had a problem. This whole thing kind of started with SolarWinds a few years back. And from my experience as a penetration tester, I can definitely tell you web application is, people are pretty good at that. Web application security, cloud security, they are getting better. CI/CD security, oh my God, I love getting into CI/CD because normally it's kind of a walk in the park. And while this is amazing as a penetration tester, and it's like, yeah, it always over time gets a little bit boring. And since we're trying to secure systems in the end, it's actually a problem. That's why I can't stop talking about this topic. So let's dive in. First, to get everybody on board, what is a consumer's perspective on a supply chain? So everybody knows what we're talking about here. This is the Salsa supply chain diagram. Salsa is a cool initiative. Check out the links. By the way, you will later get a link to a repository of mine where you see everything that we did today, step by step, indicators of compromise, object deliberations, tampering, detection, protection, rating as an attacker, but also my slides, and so on and so forth. So you are good. Just keep your ears pierced now. Salsa supply chain diagram. It's a really cool initiative that is trying to secure supply chains. And when we are a consumer, we see ourselves like over here on the right where the red arrow is. This is us. And this is what we consume. We consume what we call distribution. So when we are a consumer and we want to use something from a supply chain, say, for example, actions checkout, the GitHub Actions action to check out code in a pipeline, we're going to look at that in a minute. That is what we consume. And this here, we don't really care about normally. And this is maybe a problem. That's exactly what happened in the NPM breaches. We are over here. We are consuming a release here, and how this release got into being, who the producers are, what the source code looks like, how the build looks like, and what their dependencies are is kind of not of our concern. I see, or in my last job as a penetration tester, I saw more and more companies actually paying attention, at least to their direct third-party dependencies. They paid attention. They checked the source code with with SAS tooling, like static application security analysis tooling, that just runs checks on the source code. But what they kind of overlooked most of the time is actually the build over here. And this is what we are going to look at. So what is the perspective of a maintainer? Don't lose me here. Right now, we just thought about, hey, when we normally consume something, what does it look like? Now we switch. We say we are maintainers of such a release. We are the maintainer of a famous NPM package that people, like millions of downstream people, consume. So then we are this over here. We are the producer. And all of this is under our control. Source, most definitely, and the build. The dependencies are also under our control, at least to a point where we can say we want to depend on that or we don't want to depend on that. Sometimes we even host these dependencies ourselves if we like have a little zoo of different tooling that goes together. But sometimes it's also a third party and it's kind of out of our reach again. So the distribution is sometimes under our control. We are going to look at that. Like it really depends where we want to release our stuff to. That's a topic that we're going to talk about today. We're just going to focus on GitHub, but there are other platforms, aren't there? So and the consumer over there is our user. So we now just think from left to right, the other way around. So now we did a little bit of theory. Now let's get diving into the practice. We are going to set up a benchmark release together. I created a new repository that we're going to populate together. So you see, hey, what does it look like to go from source code to a release? I'm going to give you a very short primer here. First, source stage. We are going to have a file called original.txt. This is the original file. No tampering has happened. This is just a txt file. And we're going to treat this file as if it were our application code. Of course, normally application code is like tens, 20, 30 of files. Here, we're just going to stick to this. Normally, application code later in the build stage is also being built, compiled, whatever. We're not building or compiling anything. We're just copying stuff over. This is really a proof of concept as minimal as possible, so it's very easy to understand, because the more complexity we would add here, just for an example, the more hard it gets to understand this stuff. So that's the second, and we only have two files. That's our second file. It's a GitHub workflow release YAML. You see down here where we would store this file, .github/workflows. We put YAML files into that workflow to then define our pipelines in there. And as I said, we're going to look at how these pipelines work. And I will explain what exactly this code does right when we dive into it. And then we're going to go to the build stage. But first, we switch over. We are now in a GitHub repository, offensive actions, that's my GitHub handle, and I opened a new repository, Pwned Labs release tampering demo. And as you can see, this is completely empty right now. So let's fill it up. Let's maybe just add a file. So we can click here to create a new file. This file will have the content. This is the original file. No tampering has happened. And we will name this original txt. I'm going to commit that. Copilot is thinking, add original txt with initial content for our release, for our repository. Perfect. So we have the first file. We also kind of want to add a second file, as we just said. And this one is going to go into the folder .github/workflows. And we are going to call it release YAML. And you see, once we type in YAML, it already starts populating stuff over here like, hey, you could use this action or that action, but we did write our action ourselves. And I'm going to paste it in, and then we're going to walk over it. I'm going to zoom in a little bit. I will zoom out again in just a second. So we have 19 lines of code over here. The first one is just we name the workflow. It's called create release from tag. So, okay, that's pretty self-explanatory. So what are we going to do? On push, so whenever someone pushes to this repository and there is a tag that starts with V and then something else, we see a wildcard. So a tag, a version tag. Whenever this happens, please run the job that is defined here. So it's called semantic versioning. When you say, hey, tag version 1, boom, you push that, this workflow is going to run. And what's the workflow going to do? Now it's going to create a release. So we're going to call this job create release. It runs on Ubuntu latest. Ubuntu latest is normally a GitHub action, a GitHub hosted runner. That's just a virtual machine that's sitting somewhere. It's actually, interestingly enough, a virtual machine and not a container from all I understand. That's sitting somewhere. And GitHub takes care of all of that. We just have to define it here. And as long as our code is open source, GitHub does that for free. It's pretty cool. So we don't have to take care of any infrastructure. And then we say, hey, we want permissions, contents right. Why do we do that? In our pipeline here, the principle that's running in our pipeline is going to be called the GitHub Actions bot. Needs write permissions over our repository, so it can actually go ahead and write our release into our repository. We're going to look at that in a second. And then we have two different steps. The first step is named checkout, and it uses actions/checkout in version 5. What is this? For everybody who doesn't know that, let's follow this. I copy this, and I go to github.com, and I just paste this in, actions checkout. And a GitHub URL is always built like that. You have first the GitHub domain, then you have actions, that's called the namespace. In my case, that's offensive actions. Now you know where this name is coming from. And actions actually does belong to GitHub themselves. And then a repository name called checkout. So if we follow that, we see actions checkout. That is a big repository that takes care of checking out your code. You would say git clone or something like that is pretty easy, but that can also get pretty hard. So they went ahead and gave us this, so we can just reference it with uses actions checkout and then start using it. We can specify a repository or a ref, a token, and so on and so forth. But we are going to keep it very simple here. We're just going to say, hey, we want version 5. You remember, that's their tag in this case, because we need to check our code out. We created code, original txt, and we need to check it out into our pipeline. And once it has been checked out, we create a release. That's the next step here. So what we're going to do is we run GitHub release. GitHub is the GitHub CLI tooling because we are on a Linux container, as you can probably guess from the name Ubuntu latest, sorry, not container VM. So run GitHub, and we're gonna do something with releases. We're gonna create the releases for the repository, which is ours, for the ref, which is ours, that is actually the version tag, and then for the file containing the file original txt. So we're gonna create in our repository a new release called version 01, whatever, original txt, containing the file original txt. Using the environment variable GitHub token that GitHub puts into here, we gave this token write permissions earlier. So now we really talked in depth about this file, but I think it's really important because if you don't understand this here, the rest of what I will speak about is going to be gibberish. So we're going to commit our changes. Copilot is thinking again. We are going to commit directly to the main branch. That's what security professionals do these days. Perfect. Now we have our little repository going. And now we're going to go ahead and we are going to clone this. So give me a second, because we need to create a version now. So what we're going to do is gh repo clone. We're going to clone this. This is directly on my developer machine right now. For whatever reason, it has to think a minute. Okay, just took a second there. And then we're going to cd right into our cloned demo. Hopefully I have tree installed. I do. So we have original txt. That's the original file. Perfect. And if we look at the git log, we see we have 2 commits, but we don't have any tags. They would show up here in yellow. So what we're going to do is we're going to go ahead and tag that. And that works with just saying git tag version 0. And then we git push -- tags. So a new tag has been pushed. And if we look at our git log again, we will see we are still, our head is here on main, but with the tag v0. It's interesting. You can have several tags on one commit, something we might look into later. So now we jump back to our GitHub GUI here. So what we just did is we cloned our code. We said, hey, this code looks perfect. This is something we want to release. We tag it with version 0 and we push that tag. Let's do a reload. And then we see over here, the release is just populated. A second ago, there was nothing here. Now we see releases with version 0. Let's go over there and investigate. What do we see here? We see GitHub Actions released this now. Why does it say GitHub Actions? Because it's the GitHub Actions bot. The bot runs the pipeline. Perfect. And it has 3 assets in here. We have the original txt, and we have the source code. Source code in zip and tar gzip is always in here. Interesting for us is original txt. When we download this, you see I just tried it out earlier. We open it up. We see this is the original file. No tampering has happened. Perfect. That's exactly what we wanted. Nice. So we have our baseline release. And now we're going to see here under actions, we see one workflow run. We can actually go in here and understand what exactly happened. So triggered via push 1 minute ago. So yeah, that's exactly what I did. I pushed a tag. The workflow run went for 14 seconds. We called it create release. You remember our workflow definition. And we see we always have the step setup job and complete job. That's out of our control. That's something GitHub does. But we have and post checkout. That's also a GitHub step. But we have these 2 steps under control, checkout and create release. You remember we use the checkout action. When we scroll down in here, we see what exactly it did, synced this repository, did run the action checkout, and so on and so forth. And then it created the release. And you see exactly the command that we ran, create repo, offensive actions, blah, blah, blah. Perfect. Now we have a version 0 release, and hopefully are quite happy with that. The next step is that we're going to go ahead and we're going to mess around with that. Again, I'm going back to my slides. That's the build stage. We looked at that, and we looked at that. What's important here is we released to GitHub themselves. Under GitHub releases, we could have also just released to NPM there or to any other store, PyPy, the Google Chrome extension store, VS Code, whatever. we build something and we push it somewhere, normally with tokens, sadly, normally with long-lived tokens. NPM is about to change that. That's pretty good. Perfect. Now let's change our perspective. We decided we are going to be a malicious maintainer. Why are we going to be a malicious maintainer? It doesn't really matter for us. Either we got hacked and someone else is us now. Okay, so they are going to poison our pipelines. Could also be that someone came around the corner and was like, hey, you have this really cool application there and people depend on you. Why don't you take my $10 million and retire in the Caribbean? Probably would look for another place than the Caribbean, but you never know. It would. I'm German. It would be taught for me down there. But you get the idea. Important. We don't speak about hacking into repositories here. We are already maintainers and we are malicious. And we have one goal. Our goal is we want to poison the release. Our output that we saw, this over here, the release is when someone goes here and downloads this should be poisoned. It shouldn't say, hey, this is totally benign, blah, blah. It should actually say, this is really malicious. And we don't want to change the application source code because we are thinking that's too noisy. People might go in here, they look into our code, and if they right here in the original txt file find, oh, this is very malicious, they might get suspicious. Or they use SAS testing on that. So very important also to say it is a shell game. This has nothing to do with CVEs. We abuse features that are in Git and in GitHub themselves, and potentially if you use other release things, obviously. Perfect. So attack number one, we are gonna meddle with a mutable release. Let's go ahead and do something real quick. Always amazing to go off script. We'll see if that works. I copy paste this directly from the repository that I'm going to share with you later. I'm going to explain real quick what happens here. We're going to use the GitHub API for our repository, Pwned Labs release tampering demo, and we're going to check the releases. And then because we're going to get back a huge JSON, so we're going to put that into JQ and only show some things that are relevant for us. Wonderful. It doesn't find the releases. That's exactly why we don't just go off script in a live demo. Repos, offensive actions, Pwned Labs release tampering demo releases tags version 0. Can't iterate over null. Okay, then we can't iterate over null. I can tell you what I would have seen here. We would have seen here that our release was created by the GitHub bot. When we go back to our releases, we see GitHub Actions released this 6 minutes ago. What I actually can do, because I'm the maintainer, I can go in here and I can edit this release. I can click edit. And then I cannot only change the release title or actually add a release title in the description. No, I can also actually go here and change the assets. I could, for example, just delete this original txt asset. And then and then I could just upload something else, attach binaries by dropping them here, or select them, binaries or txt files. I could just drop that here, and then I click update release. I'm just gonna do the deletion. I'm not gonna upload something else. We do update release, and as you're gonna see, all of a sudden we only have 2 assets. I could update something else. Echo foo into original txt. Let's upload that real quick. We update with the release. We again have a original txt. If you paid real close attention, you probably saw that the SHA has changed. And when we download this now, we see it says foo. So this is because this is a mutable release. It's totally normal for GitHub Actions to have mutable releases. That's the absolute default. GitHub recently introduced immutable releases, and we're going to talk about them in a second. But for now, let's go ahead and do our first attack. We are going to meddle with a mutable release, because what we did right now is you will see that GitHub Action released this 8 minutes ago. But if we look into the API, we will actually see that original TXT has been uploaded not by the GitHub Actions bot, but by offensive actions, not of type bot, but of type human. So this is standing out potentially. So we are going to go ahead and we're going to change that. How are we going to go about that? First, we're going to go through my slides to understand what's going to happen, and then we're going to do it. Here you see, okay, this is what I kind of wanted to show you. That's a screenshot of what I wanted to show you just now. We see, hey, this asset named original TXT had been uploaded by GitHub Actions bot. We just did that. But now this is what it looks like. Offensive actions type user. That sticks out like a sore thumb. So we need to deal with that. So what we are going to do here is we are going to run our release YAML workflow, the one that we put together. And we are going to create a release version 1. But before that even starts running, we are going to start another workflow called tamper release. And in this tamper release, we're going to go ahead and we're going to check, is there a release? Is there a release? And once a release is there, we're going to overwrite it. So the time difference between creation and upload of our new meddled with file is not going to be 6 minutes as it was just now. It's just going to be like a second, maybe even less than a second. So maybe it's not even going to show up because we just see seconds and not milliseconds here. Perfect. And then this is actually what we want to see when the meddling has worked. So we are going to go ahead, pub, and do that. We're going to go back to the code. And we're going to open branches, and we're going to go to the main branch. We are going to open another new branch called alter release. We're going to create this branch directly from main. So for now, there are no changes. We have alter release here. And then we're going to create a new file. And this new file is in .github/workflows. And we're going to call it alter release YAML. Again, you see it detects we want to put a YAML file here. Let's put a new workflow in here. So this one we can talk about real quick. We name it alter release. It happens on push. So not on push of a specific tag, but on every push to this repository. And then we're going to go ahead. We still run on Ubuntu latest. We give it write permissions because we still need to write to our repository, but we only have one single step. It's called alter release. We directly run a bash command that will go like this. Echo, this has been changed after the release from another GitHub action run because the release was mutable, and we write that to original TXT. So that's the only file that's present within this VM then, like for our workspace. Then we check until GitHub release delete asset version 1 original TXT. Until that works, we sleep for 2 seconds. And once it worked, we are done. Perfect, nothing else to do. And then for the release version 1, we're going to upload the file original TXT that we just wrote here that has been changed. And that's it. And the beauty of this is when we start this, you know what we're going to do? We're going to commit. And with a commit, we push. And this workflow is going to start running. And we can look at that in a second. We commit our change. Perfect. The branch is one commit ahead of main. And let's look over to the actions. And we can see there is another new GitHub Actions workflow run that started from our branch alter release. And yellow is indicating that something is going on here. It's running. So let's see in the logs what's actually happening here. Okay, GraphQL could not resolve. That is not intended. Yay, GitHub changed something. Pwned Labs release tampering demo. Pwned Labs release. Yeah, I can tell you exactly what happened, and that's the problem from earlier. I don't know if any of you spots it. I spot it. We see Pwned Labs dash, and actually, for whatever weird reason, I gave it underscores here. Okay, cool. So we're gonna cancel this workflow, and we're gonna fix this. It's gonna cancel. It's just gonna be a second. Let's hope that fixed the problem. I even checked that earlier, and then I made a mistake in my preparations. But that's normal when you run live demos. Cool. So again, we're gonna go to the alter release branch. This time we don't have to create a new file. We already have the file sitting here, alter release. We're gonna go on edit. We're gonna overwrite this. Let's check. Yeah, this time it's underscores. Perfect. And then we're gonna commit this change again. Let's see what the action now says. As you can see, we stopped this one. We go into auto release. The job is starting, waiting for a runner to pick this up. Release not found. That's looking better. That's exactly what we are looking for. Every 2 seconds now, it's going to check and see if this release has been found. Perfect. So now we're going to go ahead without changing anything to our code. We're going to do a git pull. So we see the new branch that just came in. We're going to do a git checkout version 0. As you can see, we are in detached head state. You can't only check out branches, you can just check out a tag. Then we're going to tag this git tag version 1. And then we're going to go ahead and do git push -- tags. And when we run a git log now, we will see that we have a tag version 1 and tag version 0 on exactly the same commit. So you would probably think that the release that comes out of that is the same, should be the same. Now let's see. Let's go over to the actions. Now we have 2 workflows running here. Hopefully they're gonna turn green in a second. This one is queued, this one is in progress. Gonna wait for a runner to pick this one up. I really hope GitHub isn't throttling me now. If you recreate this yourself with the repository that I gave you, you sometimes have to just reload this tab. Still queued. Why are you queuing me? Job is about to start, running on the hosted runner. I had some timing problems with GitHub earlier this afternoon. I hope that's not aftermath of the AWS outtake yesterday. Like, I'm guessing most of the GitHub stuff is actually hosted on Azure because both belong to Microsoft, but you never know the side effects. So I'm sensing there is a problem here. Normally that takes way, way, way shorter to be picked up. Everything's looking good. I think this is actually a problem with the underlying GitHub infrastructure here. This one is still running, release not found, everything is good. Well, that's no fun. Still waiting for a runner to pick up this job. That's kind of sad. Ah, cool. Okay. I just wanted to say, you know what? We're just going to cancel this. Nice. That's a green check mark. Sometimes you're just going to have to internally let go, it seems. My machine realized, or GitHub's machines realized that I was about to give up. Perfect. Now we have 2 green check marks. Woohoo! Let's look into that. This one on our malicious auto release workflow had a job. Release not found. It asked 120 times and then was able to delete it. Asset original txt not found in release means, yeah, I was able to delete it and then I uploaded it and didn't give us any output for that. Let's go over to our releases and let's look at the original txt here. This has been changed after the release from another GitHub action run because the release was mutable. Wonderful. It actually did work. Woohoo! So now you saw the first one of our exploits in action, and we are going to look at the indicators of compromise now. The first one actually might not be available yet because GitHub states that this API it can take 6 hours to populate. Let's see. But it actually has it. Wonderful. So we have, it's called the releases API. So Pwned Lab release temporary demos / events, like the events API. So it collects several events about open source repositories. So here we have the release event. The action is published, and there was one asset connected to it, original txt with this digest, and created at that time. Now we're going to go ahead and we're going to get the exactly same data, but not from the events endpoint, but from the releases endpoint. You see the difference? Up here we have events. Down here we have releases. Ha! That is really cool. We actually did get lucky. As you can see, the publish event, like we got lucky as attackers. That is not something that is, in my opinion, considered to be lucky on the side of GitHub. Release event, publish for version 1, and tag is version 1. The file name is original txt, and the SHA is actually the same. So that means we are talking about the same file here. It was created at 1739.00. And let's memorize the beginning of that SHA. It's 113508. If we look at here, 113508, that's the file we looked at. And that is a race condition. That sometimes happens. I wasn't promising it because it's a race condition. It doesn't always work. But as far as I understand it, the release event is published just a tiny fraction after the event actually happens. And by then we overwrote our file. So even as a very, very diligent defender, we can't actually see this attack here. Like we do not see why on earth would the content of original txt here be different from the one that we see in the code. So cool. I'm super glad. At first I was kind of frightened because I didn't get my green check marks, but that is a great outcome for us. Important as attackers. We did leave a little bit more traces. You can really get into the weeds and look into my repository because I have like JQ queries that are that long. I'm not going to torture you here with them, but I'm going to show you the little tricks that you can do. This one is a little bit like when you go to an open source repository and you see this here, kind of not great, is it? So why don't we get rid of it? delete workflow run. Yep, we're going to delete this one. And that one we're going to delete too, because it just doesn't look great. Wonderful. Things are way better. Now let's go back to the page and call actions again. That's what a defender would do. They only see create release from tags and our 2 workflow runs that are numbered consecutively. Wonderful. Perfect. Looking quite good. Really, to see this as a defender, you have to dive in deep into the APIs. Perfect. I'm looking at the time, and I will actually press the tempo here a little bit. And I am going to do my absolutely beloved other attack. We have in the repository, we'll find 5 different attack vectors. I will be able to show you 3. We already saw 2 of them. And this path here is my absolute favorite. So what we can do is we are going to go into our workflows and into our release. And as you can see here, we use actions checkout version 5. When you look it up, GitHub actually tells you v5 is a bad idea to use. I don't know how many people of you are actually well versed in this, but that, as we can see, we can change tags. We can remove a tag and put it somewhere else. So what we can do here is we could, in theory, instead of using v5, we could use the latest hash of a commit to tag to that. That is supposed to be like a security best practice. However, we will be able to create something in actions checkout that we can reach from our own commit, and we can influence the code in that. I will show you how that works. It's called a dangling commit. For this to work, what we're going to do is first we're going to fork actions checkout. GitHub.com actions checkout. We actually went here earlier. You remember. And if we scroll down, they tell you to actually use actions checkout version 5. So right now we are doing what GitHub is doing, but we can be even safer. We, in theory, could go ahead. We could grab this hash here. That's this commit hash and directly pin to that. I will show you what that would look like. I'm going to change our file from version 5 to this. And this is supposed to be super safe because anybody can, in theory, change a tag if they have control over action/checkout, but they cannot retroactively meddle with commits. That's just not, as long as SHA isn't broken, that's not possible. So that's in theory really cool. But who actually has all of the correct SHA sums memorized? I guess not really everybody. So we're gonna cancel the changes, and we're gonna, because if we do this here, we're just gonna land at version 5 again, or at the current main, which might be the same. We are gonna actually inject our own SHA sum. Excuse me. So what we're gonna do is we're gonna fork this, and you can do that by going to fork, GitHub Actions/checkout fork. And we can fork that into offensive actions checkout. We can actually fork that into any name. I'm not going to use checkout. I'm going to use Pwned Labs for that. Pwned Labs demo, maybe. So we only copy the main branch and we create the fork. So it is forking. Perfect. And do you see this? We reached here with the commit hash earlier. Do you see that it's exactly the same commit hash? That's how a fork works. So what we actually can do is we can replace offensive actions, Pwned Labs demo. And you see here, Salman and so on and so forth created that. We can cut that out and go to actions checkout. It's exactly the same page, just in a different namespace. I'm going to go back. Same page, different namespace. And we're going to abuse that now. So what we're going to do is we're going to go to our code. And we are going to have to go into dist and index.js. If you if you debug these actions enough, you understand where the code is being hosted. This is just, yeah, I had to look for it. And then we're gonna go very much down to almost line 1900. It's over here. So, and down here, this action gets the sources. So it actually from here copies, clones the code. So this is exactly where we want to inject something malicious. We're going to edit this file. Gonna search again for our line, and then we're gonna add 2 lines in that. So these lines here are new. We require a child process, and then we echo this was tampered from an orphaned commit belonging to the actions checkout repository into a file original txt. You kind of know that already. And we inherit standard input output, and that's all we do. So what we're going to do is first it's going to clone our stuff, and then we're going to overwrite the file original txt. We're going to commit these changes. As you can see, I'm still in my offensive actions Pwned Labs demo. Log tampering message. Perfect. Now this has been committed. And when we click here, we see this change was now. Here we have our new commit hash. So when we do the same magic again that we did before, here you see that is from offensive actions. In the offensive actions namespace, we go to actions checkout. And you see the exactly same changes in the actions checkout context. You just get this tiny yellow thing here. This commit does not belong to any branches on any branch on this repository. It may belong to a fork outside the repository. So it may, it does. So what we can do now is we can actually reference this directly in our release that we want to tamper with. And we're going to go over here. Now we are again in offensive actions in a Pwned Labs release tampering demo, so the repository that we want to tamper with. We edit the file. We go from v5 directly to this hash, but as you can see, actions checkout still looks pretty legitimate. So GitHub offensive actions. And we are going to commit to the main branch. Now we're going to do the same dance that we did before. We are going to go ahead and we pull the changes. We are going to check out the main branch. Your branch is behind main by 1 commit. It can be fast forwarded. We need to pull again. We check git log. And we see that is change checkout actions. We can say git show, and we will see exactly the diff. So we changed it from version 5 to our hash. Perfect. Then we're going to tag this with, in this case, tag the version 5, because I'm just following along what I had in the slides, so not to mess anything up here. So we're going to git tag version 5. And we're going to go ahead, git push -- tags. And we're going to pushing. We're going to go over to the actions. And as you can see, our release is running. Again, it's queued. Let's hope this time the queuing goes a little bit quicker. Oh, and now we already have the green check mark. This time it actually went very quickly. We have the checkout. And here you can see run actions checkout. And here we have an indicator of compromise. We see our malicious SHA hash. But everything else looks pretty normal. We go over to the code. We go to our releases. We check original TXT. And we will see this was tampered from an orphaned commit belonging to the actions checkout repository. This type of commit is called an orphan commit because it was actually called over the wrong repository. We can actually go ahead actions checkout. That's not where we wanted to go. We want to go to offensive actions. Pwned Labs demo. We go to settings. We delete the repository. And when we now look for our file hash, in actions checkout, just gonna open any hash here and replace it. We replace it with our old malicious hash, and you will see our malicious commit is still floating around here. We can still go ahead and abuse this, even though we even deleted the repository that we used to inject this. So that's what it's called, an orphan commit. You can not find this officially over the API. It just doesn't exist. This nice yellow warning here is not a thing in the API. There is a really cool security researcher, François Proul, and he did send me over how to maybe manage to find this. And I wasn't fully able to get it working, but I'm working on that. And once it works, I will push it into my repository. Talking about my repository, I will share with you where you can find that. It's called Release Tampering POCs. As you can see, there are 6 releases because I go through all the different steps that I found. If you scroll down, you have a long table of contents here. Intro, more theory, our initial baseline setup, and then the different attack paths. And I have 5 different attacks in here. We looked at attack number 1 and attack number 5 because this is just my most favorite attack. I hope it's amazing. But there are also attacks in how to use a typo-squatted third-party actions in our workflow, because I also own the workspace actlons, not actions, but actlons. It's just 1 character difference, but it makes a difference of all the world. We can use a GitHub hosted runner with a container hour under control. So we can just push a container to Docker Hub to pull, and the container is malicious. And we even can meddle with self-hosted runners. That is kind of involved, and it contains a homoglyph attack. So look into that and check it out. So I see that the time is almost up. That's why I kind of sped things up in the end. I hope you guys had a blast, and I am absolutely open to questions now.
So I have a question, Ben, and thank you so much, mate. That was amazing. So is securing the CI/CD pipeline as important as securing the application source code itself? And also a follow-up question, if I may. Why do you think that pipeline security kind of goes under the radar?
Absolutely. First question, yes, it is absolutely as critical to secure pipelines as it is to secure the application source code itself. If people use a tool like GitHub, that kind of in a way goes hand in hand because it's in the same repository, so the access permissions are maybe the same, but the impact is really different. And in my opinion, people, that's coming to your question number two, people have been trained, developers have been trained over years and years and decades, basically, to make their code better, but normally or more secure, but that people can actually define a CI/CD pipeline directly in their repository with code they write in this YAML file. That is kind of new. And for me, that's very similar to people being all of a sudden able, or they had to run Terraform and do infrastructure as code. People are really good at building applications because that's what normally developers strive for. They want to build a product, and everything else is kind of duct tape around it. And infrastructure as code for the cloud was duct taped, and now it's CI/CD code that is kind of duct taped. And it's just very, very easy to have a pipeline that everybody can commit to and run stuff. So that's a very long-winded answer here. And as you could see, doing incident response and analysis in these APIs is really not straightforward because you will miss information that you might see in the GUI. The APIs are different. So hope that kind of answered the question.
Yeah, absolutely. Thank you. Thank you so much for answering that. And honestly, that was a really enlightening presentation. We do have another question from Sumyanil.
Yeah. Hey, hi. Thanks for the talk. So my question is like, is there any detection point of view by leveraging GitHub audit log or something like that?
I'm so sorry, I have a little bit of trouble understanding you. Can you speak a little slower and a little bit louder, especially, please?
Okay. Am I audible now?
Yeah.
Yeah. So my question is like, what will be the detection point of view that is leveraging GitHub audit log or something? Can that be a useful thing in the incident response or the detection point of view?
Absolutely. Like for all the different attack paths, I show in my repository OPSEC deliberations that I had. Like I just didn't write up an attack that I had. I looked at different ways of maybe making an attack like that kind of works like that. And I always had several options, and I tried them out against, like I just tried them against a demo repository, and then I saw and looked how the API would behave. And so for the attacks that I showcase in the repository, I try to find like the best solution, but there is always not a best solution anyway. So I try to really point out why I chose a special path. And then I show you the tampering and the indicators of compromise after that. So that is definitely something you can directly look for. But one thing you have to keep in mind, if you're going to look for these indicators of compromise, you probably shouldn't look in your own repositories. You should look in the repositories of third-party packages.
Makes sense.
Like, for example, if you consume, like, let's look at the last application, the last demo I showed.
Yeah.
If you consume a tool and that tool uses actions checkout, you should actually go ahead and check, okay, this uses actions checkout in a special hash. You should look at that hash or the code that is hiding behind that hash and see, does this hash actually belong to this repository or is it an orphan commit?
Makes sense.
As you can see, this branches out indefinitely, and that's another reason why CI/CD security is so massively hard. I have to say, okay, I'm going to look at the next line. I'm not going to look at my own code and the direct code that I'm consuming. But you can't scale indefinitely, so you kind of have to do a best effort here, and you definitely have to script these detections. And
Makes sense. Makes sense. Like the detection engineering scenario for CI/CD security is like totally different than normally what actually is done, right?
I also have in the very beginning of my repository, I link people that did great research in this topic.
Right. Okay.
There is a company called, of course, I'm blanking now. It's their tool is called Harden Runner. It's an amazing tool. Where is it? Step Security. The company is called Step Security from Varun Sharma and Ashish Komi. And they have a tool that's called Harden Runner. It's, again, a GitHub action. That's the first action that you pull in your workflows. And what this is going to do is it's going to monitor your pipelines and your action run. And it's going to see, is this reaching out to kind of weird endpoints, for example? It's in a way like a firewall EDR combination. And they, of course, have a paid tier that is absolutely crazy, but even the free version, the open source version, is really good at detecting weird stuff. So this is something you could do basically down the line, because if someone upstream tampers their releases, as I just showed you, the effect is going to hit in your pipeline or on your developer machine. That's another reason why you should not run CI/CD on your developer machine. Right? But you put that into your pipeline, and ideally, you fish out bad stuff that is happening very quickly. That's a very good reason why Step Security is normally on the forefront of these NPM breaches, because they just have great telemetry and they see very quickly when something is going on. So we just looked here at, if I am a malicious maintainer, how do I hide my stuff? But the other thing is, what do I actually hide in there? What's my poison? Because this poison is to get around EDRs.
Right.
Those are two totally different things. One is payload delivery and the other one is execution.
Execution, right. Thank you so much. Thank you.
Absolutely.
Also a question from Joe. Go for it, Joe.
Hi, yeah, thanks. A really interesting talk. From a pen testing perspective, I'm just thinking, in your experience of, pen tests and red teams, or whatever, how effective are built-in security measures like branch policies and like forcing reviewers in preventing these? And like, if we were to find these issues with clients, what's the best recommendations we can make for them in terms of kind of inbuilt security measures in GitHub or other code repos?
Yeah. Absolutely a valid question. I have to answer straightforward with it's horrible. The controls in theory are there. The controls, if they are there, they work very well. I'm not able to get around something normally that is built by GitHub's teams, because they are amazing. There are some security researchers that do great stuff, but if branch protection is set up correctly, and if you set up your environments correctly, none of that will really get around it. But people don't do it, and that's the other thing. At my last job in a penetration testing role, what happened is people would come to me and they for a scoping, and they were like, "Hey, we have this web application. Please test my web application." And I was like, "Yeah, we looked at that already like last year. I understand you need your green check mark, but we should probably look at your cloud environment, because that's where normally more dragons are hiding. So let's look at your AWS. I see it's running on AWS. Let's look at that instead." And over time, I realized, hey, I should probably ask people to look at their GitHub too. And so after like some salesy activity on my part, I'm not a salesperson, but I wanted to test the stuff. So I kind of had to make people let me test their stuff. I often was able to get access to their CI/CD. And I basically was like, hey, in the beginning of the test, just give me access to your CI/CD as you would give to a working student, for example. Someone who's just going to be there for 2 months. Your typical, hey, Ben is allowed to have their own branch in our repo, but we're not going to like merge it into main anyway, so it's not a problem. This kind of a scenario. And I told them I would try to get around your security measures for 1 day, and if I don't manage to do that, I will reach out to you and you give me cloud credentials. I only needed to reach out once. Because in all the other times, I was able to, within half an hour, get access to the cloud. And if I got access to the cloud, or when I got access to the cloud, that was normally in a administrative role, because people normally set up in AWS, for example, an administrative role in AWS. And then from the pipeline, you can assume that role via OIDC. Yeah, and so that's what I did, and I was within minutes in an admin, because they don't use environments. They have branch protection. I can't directly commit to their main branch, but I don't need to. I can just make a branch called Ben's testing branch and have a small GitHub action in there, and I can show you something that might actually help you in that regard. I will share my screen again. Because this is how I actually started my whole offensive actions. That's where this username is coming from. I do have two interesting repositories here. The first one is very straightforward, secret and exfiltrator. It is a GitHub action itself, and you can just use it in a test branch that you can spin up at a customer, and you create this action and you exfiltrate your stuff. So this will exfiltrate secrets. You use offensive actions, secrets, and exfiltrator at main, and you exfiltrate your variables and your secrets. I would highly recommend not to just use mine, because I could be malicious, as you just saw. Use these repositories and check out what the action is actually doing, and you can just fork this or implement it yourself. And here you will, if you dive in, see that I'm just dumping stuff, base64, encoding it, and writing it to logs. This is basically what threat actors are doing too. So this will help you to very quickly just get all these logs, these credentials out of the logs. Think about which credentials you put to the logs. Some clients might not be happy with you actually putting them to the logs, because they might actually go ahead, collect these logs, and put them somewhere else. That's why I implemented here different other means, not just dump them to the logs, but also exfiltrate them to a webhook site. Probably the smartest thing is exfiltrate them to an Azure storage account container under your control, because it's gonna like go in there and only you as a penetration tester have access. Probably the smartest solution here, but a little bit more setup, because you need to set up a storage account. That's one thing. And the other thing is an Azure storage account reverse shell. There is an image here that like everything is described in great detail, but this is the image that you kind of want. If you target something and they have a self-hosted runner or a hardened GitHub hosted runner, and you can't, for example, send you a reverse shell to your attacker's machine because they put in a firewall or hardened runner, one of the two, what you actually can do is you can set up an Azure storage account and let my tool run, because you can communicate out of band via the Azure storage account. And you get basically a pseudo shell that uses the Azure storage account. It works a little bit like a C2. So when this executes, it sends back. I have another screenshot of this. Yeah. So when it executes, you run a client on your pen testing machine, and then you see an incoming connection with timestamp, and you see runner, the runner name at the machine name, and you then can enter ID, and the ID is going to be written as a string to the Azure storage account. And then the pipeline is going to pull it from there, and you can imagine what's going to happen. So it takes a while. You can't exfiltrate big data with that, but small data is normally enough, because a token is normally enough. No.
Yeah, that's really smart actually. Yeah, I've compromised runners and got reverse shells, but I've never been in a situation where it's been kind of blocked outbound. But that's quite a smart way of getting around it.
Yeah. Then check this out again. Don't use the stuff directly. Understand what it's doing, or just fork it. Then you have it under control. I'm not planning on becoming malicious, but I might get compromised. You never know. So yeah, this is something I can highly recommend, especially if I go back to this picture. As you just said, you already compromised runners. For everybody who is in the same position, if you are able to compromise a self-hosted runner, in 90% of the cases, they are non-ephemeral. That means they are not getting scrapped after the run. And they are just going to queue up and pull the next job once the next job comes in. So if you can persist on that runner, even from a low privileged repository, then you hang around on that runner, and maybe an hour later from a high privileged repository or with an interesting repository, a build job is going to come in, and then you all of a sudden have tokens to that. So that is amazing and very much overlooked, in my opinion. So try to push for a CI/CD test. Customers sometimes a little bit hesitant because they know they have sleeping dragons. But what you could do in theory, if you have that privilege in your company, You tell them, you know what, I'm here to test your cloud, but why don't I test your CI/CD? I'm going to give you half a day of a CI/CD test for free. You're gonna give me access to your CI/CD. I test this for half a day, and if I don't manage to get out of that, I will call you for the credentials for the cloud test. You pay for the cloud test, and you get a write-up for the first half day for free. Because normally, again, within 20 minutes you will be in the cloud, and I guess you can invest 20 minutes in that because you have a high impact. And the client might actually ask for that again and is like, okay, cool. If you manage to exploit this in this one team, we have 10 teams. Can you maybe check the others too? So, no. Awesome. Thanks for the question.
That was super insightful. Thanks everyone for their questions. I would like to say a massive thank you to Ben for sharing your knowledge with the community today, and also for everyone who's taken time out of their day to learn some cool new things. So thank you, everyone. This will be uploaded to YouTube today, within a couple of hours. So yeah, hope you had a great learning experience. I know I did. And yeah, we'll maybe see some more content on this in the future as well. Who knows? That'd be great. But yeah, thank you so much, everyone. And if you have any questions for Ben or anything about this, put it in the channel, and yeah, we can hopefully have more discussions there. So thank you so much, everyone, and hope you have a great rest of the evening ahead. Ben, do you maybe have some closing thoughts for us before we go?
In case you have access to your company's pipelines, go ahead, do it now, do it tomorrow, look at your stuff, and I am fairly certain you will find great detail. In the beginning of my repository, you will find great resources of other researchers that have done great things. There is, for example, Adnan Khan. He has an offensive toolkit called Gato-X, and there is also one for GitLab now from Praetorian, his old company, called Gelato. Use these. It's going to make you faster, but try to understand what's happening. I think that's the way to go. And hack all these pipelines because they are hackable and it's fun.
Hack all the pipelines. Great final words there. Thank you, everyone. Have a great rest of the evening and a great rest of the week ahead.
Thank you, guys. Thank you, Ian. Bye.
Thank you.
I love Pwned Labs.
Woo! Me too. Hey, Cookie D, I see you.